Welcome to the SCG Europe Regional Advisory Committee's Technical Webinar Series, Geophysics for Today and Tomorrow. Today, our presenter will be Kurt Strack, who is President of KMS Technologies and KJT Enterprises, Inc., specializing in integrated seismic electromagnetic technology for land and marine exploration, appraisal, drilling, and production monitoring for the geothermal and petroleum industries. He is also CTO for Responsible Energy Services International, Inc., that provides data acquisition services to the green energy industry. Present emphasis is to drive the technology enabling smooth energy transition to zero carbon footprint. In addition to his industry career, Kurt has also had a distinguished academic career in Europe and Germany, in Asia and China, Thailand, Indonesia, India, and also in the United States, where he currently is co-supervising many master's and PhD students and postdoctorate students. His company, KMS Technologies, pioneers borehole to surface, and land and marine electromagnetics as linked with the 3D seismic Earth model. Previously, he was chief scientist for Baker Atlas after various management positions. There he built their research and development and supported the development of numerous new logging tools. Prior to that, Kurt pioneered LOTEM, transient electromagnetics for hydrocarbon exploration, development, and advanced borehole geophysics technologies in Germany, Australia, and the United States. Kurt also serves as adjunct professor to the Earth and Atmospheric Geoscience Department and Electrical Engineering Department at the University of Houston, Mayadal University in Bangkok, and at Yangtze University in Wuhan, China, borehole geophysics and electrical methods for petroleum applications, and other universities in China, Malaysia, Indonesia, Saudi Arabia, and also in Germany. Kurt received a PhD from the University of Cologne and a master's from the Colorado School of Mines. He also did graduate work at Marquette University in Australia, an MBA course in the United States. He worked for over the past 25 years as a consultant, university researcher, and R&D manager in the geothermal and oil industry. His geophysical work started with internships in astrophysics in the Middle East and nuclear properties of materials in Eastern Europe, followed by earthquake analysis and thermal conductivity methods developed and geothermal exploration in the United States. After that, he focused on electrical magnetic methods for oil and gas and geothermal industries in Germany. Subsequently, he spent a decade developing new logging tools and methods in logging industry. In the past 20 years, he has built novel equipment for land and marine electromagnetics and seismic, present being applied to CO2 monitoring. Kurt has over 200 publications, one textbook, and co-authored or authored more than 40 patents. He received 2 Fulbright scholarships and numerous international grants and awards. His interest is integrating geophysics with other disciplines, technology transfer, and project development. He's a member of SPWLA, AAPG, ASCG, BDG, DGG, EAGE, EEGS, GRC, SPE, SCG, and TSCG. He was co-chair of the technical program for the IPTC in Bangkok in 2012 and active in many communities. He was the industry representative on the IAGA EM division and still provides frequent workshops at their biannual meetings. The SPWLA granted Kurt a Distinguished Technical Achievement Award in 2003 for new logging technologies. SCG granted him the Regional Fessenden Award for the development of through-case resistivity in 3D induction logging. The Russian Academy of Science elected him the foreign member and gave him the Kapitsa Gold Medal of Honor for his innovations to borehole geophysics and pioneering work to surface geophysics, mainly LOTEM. Kurt had served as distinguished lecturer for SPE in 2018, 2019, and SPWA for 2004, 2005, and in 2007, 2008, he received the SCG President's Special Service Award. In 2012, Kurt is co-recipient for the KMS Technology Cecil H. Green Enterprise Award from the SCG. So without further ado, let's welcome Kurt Strack.
Good morning to everyone. Thanks for joining. And as you noticed, it's quite embarrassing to have such a long biography. And when you edit your biography over the decades, the part that you never get correct is, of course, your experience. So I guess 25 years was 2005 when I started editing that biography. So I'm significantly older than that, and supposedly close to retirement, which I already attempted once to do 10 years ago. So without further ado, today I have less slides than usual. And let me just see how this thing goes forward. I previously talked about electromagnetics as integrated for fluid imaging, for geothermal, subbasalt, subsalt, and EOR and CO2 monitoring. What I didn't cover is borehole and airborne EM. Both areas, electromagnetics is actually one of the major geophysical tools. And I spent actually most of my career looking at new borehole tools. So here, I was looking at how do you talk about your own career? It's sort of like a bragging about what you've done. So let me be a little bit more sarcastic about it. I'm supposed to motivate young students, and that's of course the last thing I want to do, because our industry has very, very, very strange cycles, and many of those. So if you get into geophysics and you get into the industry, be clear you are doing it to sustain your lifestyle and not for some other professional motives. And I often see that young scientists have still a very idealistic view of the world, and then the bad management in our industry, which are also geophysicists and geologists, make sure that we cycle up and down and we all get a shock. So I looked at some people, some of my colleagues talking about their career, and so let me just give you a little bit background. How did I get into applied geophysics? And I decided very, very early on, namely in high school, that I wanted to do applied geophysics. And I give you some highlights. And the reason why I give you some technical highlights of those developments I was involved in, or I was fortunate enough to share the development, because I think you can see that we are trying to combine a lot of this to get a better linkage between the borehole and the surface, which is extremely important for the transition to new energies. And that will be going on for quite some time. And of course, I give you throughout some wisdom and what we're going to do. And I was asked last time about cloud applications and deep learnings, and I was very circumspect about it because I didn't really want to share too much about it. But in the meantime, that's no longer something that I keep in the back burner. So how did I get into applied geophysics? I grew up in Germany. And in high school, the last year, the teachers are trying to help us making a decision what we're going to study at university. And we had a very lazy French teacher who actually was a hobby geologist. So instead of teaching, he would take us walking in the forest and explain the geology to us. But since we had 2 hours of French, after 1 hour, we were sitting back in class, and he was then looking at what do you want to study, blah, blah, blah. And he had a list, and on the list was geophysics. And I said, what is geophysics? And He said it's a combination of geology and physics, and I loved physics. The next day he brought me a book about 2 inches thick, and it was Fisher's Dictionary of Geophysics. He says, read this. And I took it home and I gave it back, wanted to give it back to him a week later. And he says, no, you can keep it. And that was essentially the beginning of me deciding to study geophysics. And it was also clear to me that I always wanted to do something practical. I was very frustrated with classroom knowledge when people can't put this in practice. And that went through my entire university career. And I earned my support for the university working as a sound engineer, and that was even more practical. While I was studying, my boss in that company where I was working, he insisted I would study because I really loved working as a sound engineer, and kept saying, no, movie theaters are something of the past. You go to university. And so he sent me doing all kinds of stuff. I did an internship in astrophysics in the Middle East, in Israel, and worked in nuclear engineering on some very strange military research in Prague, and ended up studying in the United States at Colorado School of Mines, where I got my master's. Subsequently, I went to Macquarie University in Australia for some PhD work, which I then finished in Germany. Now I am stuck with on 3 continents, and I have family and homes in Germany, Texas, and in Thailand. And I really can't tell you what is my main home. At the moment, I'm in Texas, but 2 or 3 months from now, I'm in Germany again. And other years, I'm the whole year in Thailand. My dream was from the very beginning, when I met my PhD supervisor from Australia in Colorado. He visited me. I of course wanted to do multiphysics inversion, and he said, no, that's too easy. You are not going to do that. You're going to do something else. And we started dreaming about sub-basalt applications, because countries like Brazil and India desperately needed electromagnetics to see the sediments below. That was 1981. And today, electromagnetics is standard for exploration in both countries. In order to get where I wanted to go, I quickly realized I needed to quickly finish my academic credentials, and after the academic credentials, tried to get back to industry. And I worked in industry between my master's and PhD for a while. And more by default, I got pushed back into the commercial work. I will talk about some technical highlights, and Laurie has already mentioned LOTEM, which is a controlled source EM method. And I don't very often talk about borehole geophysics anymore, unless I teach a course in China. And they've been very good, actually. They've built some innovative through casing resistivity tools based on the principles of time domain electromagnetics, which is really, really impressive. And I'll talk a little bit about AM hardware, because that's what I'm doing now in my company. First of all, LOTEM, when I started this in 1980, and I would give presentations in all companies, I was sometimes keeping my fingers crossed behind my back, hoping that everything I was saying is correct. Well, today we know it all works. We know it can find oil, and we are at a point where we could not be in the 1980s. We can model and interpret the data with full 3D anisotropic models. And we also realize today, if you do not use 3D anisotropic models, the error you do with surface measurements is in the order of 30 to 50%. So we were really poorly equipped in the 1980s to do this. You see here a transmitter at the surface which injects a current, and then this sends a signal in the subsurface, and you have a number of receivers. One of them is here, and that measures the response from the signals, and you interpret this part. This happens to be our transmitter in China, and the generator is on this truck here. I'm only giving you some highlights. So instead of showing you the data or the equipment, I have some equipment pictures at the end. I think I give you as takeaway some of the methods. One of the most difficult logging tools in the past 100 years was to measure resistivity through casing. And while we were developing it, there were all kinds of reporters coming to us and saying, oh, you're working on this. This is the holy grail of the industry. And I just looked at it. They are right. We had no idea whether we would ever be able to measure it. Why? This is the borehole. Here is the casing. The casing is at least 1 million times more conductive than the formation around. The formation around is something like 3 to 10 ohm meters. The casing is 30 micro ohm meters. So what you do is you inject the current anywhere, doesn't matter where, and then the current goes up the casing back to the surface because it's so conductive. So 1 million times more current goes through the casing than here into the earth. So if you measure the current flowing through the casing at 2 spots, and you take the difference, then you know exactly how much goes in the casing. And measuring this current and taking the difference is the difficult part. You have to mix very, very careful noise and signal and interference considerations, and that's the part that took 60 years. Oh, the machine has its own life. This is the part that took 60 years, is the measurement of this, and I'm not getting into this. But you can do it, and this tool is now commercial. People can buy this from the logging companies, and it works very well. Now, in the context of overall voltages and logging tools, lateral logs, which are in existence since the 1920s, and they had their big time until 1949, when the induction tools were invented and deployed predominantly in the Denver-Julesburg basin. And the way they pushed new technology is at that stage, Schlumberger took all the lateral logs away and only gave them induction tools and says, this is what you run now. But the induction tool measures smaller voltages in the microvolt range. The lateral log measures millivolts. So this is easy to build. This is okay, you can build this also. But through casing in the 90s, measures in the order of 10 to the minus 9 nanovolts. And the noise level of copper wire is just around 2 to 3 nanovolts. So you are right at the noise level of copper wire. So this is very difficult to do. You have to use all kinds of tricks to get the signal out of the noise. So the challenge in 2020 is still to measure a deep reading tool which looks 50 to 100 meters away from the wellbore, from inside the wellbore, because this measures like 2 to 3 or 4 orders of magnitude lower voltages, something like 10 to the 4th times below the noise level of copper wire. And the only way to do that is to couple geophysical data processing and signal acquisition principles and very, very complex electronics with the tool itself. And then you can even do this part. Another interesting tool which was necessary, and one of the main reasons why I went from surface geophysics and left academia and went to industry, is that you couldn't calibrate surface measurements. So what are they good for if you can't check your results? And the reason why is that induction logs measure horizontal resistivities. When you do controlled source EM measurements, you measure vertical resistivity. So you really need to know the vertical resistivity. There's no logging tool to measure that until the development of the 3D induction logging tool. And until the tool was actually developed and running commercially, the industry thought it was impossible because you have to put induction coils horizontally in the tool itself, and they become much smaller. And I'm in this office here. Let me show you something. So the first laboratory mock-up prototype we built is actually here. And where is the camera? So this is a 3-component transmitter or receiver, which has the components mounted on a wooden carrier. And we use this to test these principles in the laboratory. Obviously, we never used the wooden one in any other prototypes, but that's how we started. And the engineer that built this gave this to me. So what you do when you have horizontal coils, you generate a vertical induced current flow, and when you measure it, you get the anisotropy. And you can now correlate the measurements to surface measurements, and the resistivities are right on. Also, we found out that if you look at the vertical resistivity, in particular in shale reservoirs, you are estimating the oil correctly, and the error done by measuring only horizontal induction measurements is that you are missing about 20 to 50% of the oil in place. So this is an extremely valuable tool with many applications. Here is an example of the original motivation to develop a DPM prototype. And when we looked at this, we were looking at a horizontal well and mapping the oil-water contact 50 meters away, because the wells cost a lot of money, in particular offshore. And this was for many decades one of the highest value project in the entire oil industry, not just in the service industry, also with the oil companies. And when you look at this, you're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 orders of dynamic range. Almost impossible to do. But you can do it if you do it correctly. I apologize for this jumping. Oh, it says 13 decades. So you have to use tricks to do that, and to signal processing geophysicists, those tricks are well known. They include sensor design, filtering, stacking, increased transmitter moment, and etc. And we actually built a laboratory prototype and proved this principle as working in 2007. So it should be very easy for us to build this now, in particular since we now manufacture sensors for magnetic and electric fields on a commercial basis and use them for all kinds of surface and space applications. And this used to be the lower threshold, and you need to get below. Of course, you can't do that just through measurement. Another interesting part that we learned is if you combine the physics of multiple methods, and here we have a 3D display projected to the 3 planes of looking at parameters in the borehole like depths of investigation, mud resistivity, and the resistivity of the earth. And you look at, and I'm not going to explain the details, but if you look at one of the measurements, you get large error ellipsoids projecting to the axis. When you combine these measurements, they get better and they get tighter together. And that's what multi-physics applications is really about. And I'll talk a little bit about hardware. When we started this in 1981, when I started as intern and ended up after 6 months being in charge of the entire operations. And I told my boss, well, you can't do that. You can't put me in charge. I'm just an intern. And he looked at me and says, yes, we can. I said, do I get more money? No, you don't. So anyway, we would take PDP-11 computers run by generators, which made a lot of noise, and with keyboards and oscilloscopes. I still have one of these oscilloscopes in my garage, Tektronix 603, to the field and measured essentially the response. And here in the Imperial Valley in 1981, we found the Brawley field, which subsequently the company I work for drilled. And it's a producing power plant with 30 megawatts today. And we did some more work there about 8 years ago, and the Department of Energy lost all information that we provided at that stage. There is absolutely no historical geoscience data there, but they're producing. Then I reinvented a system and built a smaller system in Australia. The CSEM switch is in this wooden box. I borrowed the generator from the CSIRO and put it on a truck. The cable is here, and used every student and helper I could find to help me with the fieldwork. So I had no clue. I ended up as an equipment manufacturer at that stage. Then when we did some measurements in 1987 for the German deep drilling project, we had to mobilize all the equipment we got. Well, I got a bus at least, but I got the oldest part of the equipment. Everybody else got better systems. So this is me sitting in the bus, and I made this ugly bus with this ugly equipment a little bit nicer by adding some flowers. Subsequently, we made a more industrialized system with one of our industrial collaborators. And here, that system that you saw in that big bus is now in this box. It's still a stripped down deck computer. We are still using a keyboard because in 1988, laptops were just about to come out. I did program a touchscreen, and I still have that touchscreen sitting in my garage too, but I never had the time to integrate the drivers at that stage. So we were left with a keyboard. And the same systems were used a year later in India very successfully by an Indian crew, and the results were just really perfect. Still one of the most perfect CSEM data. Then I mentioned already through casing resistivity, TCR, which was invented by Benning Vale, who spent his lifetime inventing it. And here, I guess he's actually I guess that's him on the right. And the tool is being hoisted in a test well in Colorado, in Rifle, Colorado, which on its own has a lot of stories about Rifle, Colorado test well. And then in 2007, I couldn't resist putting this picture in. This is the DPM tool in a test, the surface test, looking sideways to see the water layer in a very quiet area in Texas, in one of the quiet beach areas, which was not easy to find because that tool has such high frequency, because normally you can listen to every Mexican radio station with that tool. So it was quite difficult to find a quiet area to test that tool. And then Thailand, where we did some enhanced oil recovery tests in 2016. Now, today we are a hardware manufacturer. We have a small shallow borehole tool, which you can use in seismic shot holes, which have seismic and EM receivers. And this is a system, multiple receivers last month at minus 10 degrees Fahrenheit in North Dakota. And this is the transmitter, which actually will go to North Dakota in a few weeks. Now, what is the future? The future is linking all those measurements within the 3D cube. So you essentially link the borehole measurements, and there is a number of permanent installations here, which in this slide I left gray because I didn't want them to take the attention away. You acquire the data and you ship the data to the cloud. And in the geothermal case, you also do, I'm sorry about this, my mouse is a little bit fidgety. In a geothermal case, you also apply it to production monitoring. This is a field in Iceland. And then from the cloud, you can do all kinds of things, not only the data handling and communication, but the measurements in North Dakota actually were, we had two sites about 400 kilometers apart, and one site 400 kilometers apart would send the data to the cloud. In the evening, the data from the receivers was also in the cloud, and then two people in Germany and in Sweden processed the data, and the next day we could look at them in Houston as well as in North Dakota. So there are some serious benefits in doing this. As I told you, my dream was to do sub-basalt in India and Brazil, and I still remember sitting in Kiva Vozov's living room within 2 weeks after arriving in January 1982, and we both sort of said is Brazil and India, and he would go a lot to India and to Brazil, and we both pushed it, and we got to India together, so he was still involved in it. But when we did measurements in Brazil, Kiva was already too old to get involved in those. So here we have a typical site, and the data was very nice. The red in this case is resistive. These are the basalt layers. Below here, Mesozoic sediments. This is a 3D structure. This is very old. This is from the 1989. And we thought, man, we can't really do this interpretation. So I sent the geophysicist back, and he found an outcrop, and we subsequently applied 3D interpretation. And this was drilled 10 years later. And as you can see, we barely got the permission to publish it 2007. And now the oil company is interested in it again, but everybody lost the data, which I thought was very funny because there were many backups around. Too much security. Here are some of the data. At that stage, we mixed electric and magnetic fields without prejudice, and we got extremely consistent result, which is quite impressive because today you would not easily mix them. So we had the calibrations and weighting and noise very much under control. Brazil, and this is unpublished, and I'll tell you in a minute why. We tested with geokinetics MT for sub-basalt in the San Francisco Basin. And when we did the measurements over 10 days with, there were 3 people or 4 people of us on this crew, the rest is the seismic crew. They just went the next day, did the HSE, then acquired the data, and they were home for Christmas. And we gave the interpretation to geokinetics, and they said, this cannot be. The basin is 3 kilometers deep. We said, we can't see it 3 kilometers. It doesn't match the data. Well, the seismic came 3 months later, and they were shooting a seismic line. And the basement is at 1 kilometer. So the Brazilian government put the seismic line at the shallow part of the basin and wasted tens of millions of dollars. And the guy who did this got into real trouble afterwards. And then when they asked us, well, how does the MT? We said, well, we'll ask the guys. And the guys who did the interpretation couldn't remember anything because it was 3 months before that they did all the work when the seismic was processed. And these are the interval velocities. So this is an example that's a success from geophysical viewpoint, but nobody really wants to give permission to publish it because it's an embarrassment to the exploration authorities. Now, all of these things can motivate people, and also the success I've had can motivate people. But you can't have everything in life. So I end up with family, with children in the US and 2 states and grandchildren, a wife and family in Thailand, and siblings and family in Germany. That happens when you put your work first. It's not always pleasant. You work for your family, not for your work. I think that's something you should put in front of your eyes every day. And I didn't do that. It's a big mistake until my kids got older and my priorities got set straight. I put my work first. That's a big mistake. And I see this all the time. So that's why I'm emphasizing that. One of the things I learned when at Baker, I had about 45 people working for me from somewhere between 25 to 30 countries. And I don't know how many religions. And the only way to make sure you would get everybody to creativity is by allow them to bring back their own spirituality, whatever that means. That could be meditation, that could be their churches. To give you an example, I got some of the Russian Jews to go back to the synagogue, and they hadn't been in the synagogue for a long time. And it works. People are happier and people are more creative. I think it's very important that people find their own inner center if they need to be creative. You can't be running around. And creativity and the reality of big company management are mutually exclusive. So I always had to isolate myself when I had to do creative work and avoid doing management work for an extended period of time in order to be able to focus on both parts. Another part, which is in particular with the new generation underestimated, their mentor is usually the smartphone, and mentoring is essential. You can only teach if you can learn. So I've been very lucky to have in electromagnetics mentors like Keller, Kaufman, Stoyer, Vozov, and as personal mentors, Sven Treitel and Frank Levin. Very lucky. But you need to pick them and you need to accept them and you need to listen to them. There is a lot of learning there. And I still remember when I would go to dinner with Frank and his wife and we would go back, he would call me at 9 o'clock and says, Kurt, I don't go into your personal things, but I know when things are difficult and when you start out the company, it gets very tight. You're not happy. You need to know. You can talk to me about anything. So these guys know what's going on. And the same with Kiva Vozov. He also would call me up in the most impossible situations, knowing what was going on. Now, a lot of scientists say, I don't want to manage. I'm close to 65, and I tell you, I do not want to manage anymore. But management will give you freedom in science. You need to manage to control your money. And once you control the money, you control how much science you do. Otherwise, the managers that don't understand anything will tell you what to do. Do not underestimate that part. You have to do it. And the other part is also never forget your roots. You need to give back. When you have the money, sponsor students, support research, get active in the alumni, sponsors professorships, contribute. And through that contribution, you will get some really nice surprises. And you will see the new generation grow up. And I have been extremely lucky. 2 of those students that I sponsored from the very beginning are now very successful in their field, and hopefully I will be able to work with them in the next 5 to 10 years, so I can see them even taking bigger roles. Now, what's the worst part? Hiring and firing. Many times you have to hire and fire, and the worst part is when I came to the US 2 weeks later, I was forced to lay off 42% of my people. That was about the worst experience I ever had. And through all this hiring and firing, one thing I learned is that scientists want to know beforehand. They don't want to be told with a piece of paper, you are fired. They want to know a few weeks before that the job's on the line, that there are issues. Maybe they can help. Maybe they can give you some ideas. And I was once forced to fire one of my engineers, and he knew, because he wasn't going to go to India, and he was hired just to go to India. And he sat in front of me and says, we have to have this conversation. Yeah, I said, I know what this is all about. And I looked at him and I stood up, I gave him a big hug and says, you're staying. I will find a way to send somebody else to India, which was 100% against the advice from my boss. Of course, everything worked out for the best and we are still friends today. So you have to be very compassionate about some of these things. And sometimes when you manage, you have to fight against your bosses. You can't just do what you're being told. Doesn't mean you have to always fight. Scientists always like to fight. Those are useless fights. Pick the fights carefully. So, in summary, stick to your vision. show consistency and reliability. And the most important part is integrity. If you lose your integrity and you participate, let's say, in some political games in whatever company you are or university, and the politics in university is bigger than in companies because the stakes are lower. So do not get involved in those. Keep your integrity. Integrity is the most important part. Nobody will ever take that away from you. And as far as the technical area is concerned, of course, there's a vision that electromagnetics will be used for monitoring, for carbon injection, CO2, all kinds of environmental shallow applications. And you will have large combined systems of seismic and EM. And in the enhanced oil recovery mode, which might interest you, enhanced oil recovery allows you to produce more oil for the same carbon footprint. If you inject CO2 as driving the oil recovery, you get the carbon credits and you get rid of the CO2. And you can also power all of this injection and production with renewables. So you can significantly reduce the environmental impact and go towards zero carbon footprint. And of course, you know, the fashionable thing is deep learning and the cloud. And I call it, I have a friend named Klaus that I'm trying to get interested in it. So we will have large real-time data volumes and it will be in the cloud. And it's not going to happen in the future. That's actually happening today already. It's just a matter to what degree people want to share this. And with this, I'd like to thank you and I'm open for questions.
Okay, we have a question. Doesn't 3D CSEM measure vertical and horizontal resistivity? I guess the 3D CSEM is more sensitive to the RV. However, the cross-line shooting should have RH information. No?
Well, that's a convoluted question. Of course, in a 3D situation, you have it mixed. You have horizontal and vertical. But without the vertical resistivity, because the current flow is broken by resistors, with just the horizontal resistivity, it's very difficult to interpret. So you need both. If you use a grounded dipole, you measure vertical and horizontal resistivity. And with a loop dipole, you only measure horizontal resistivity. And in a 3D situation, you have every factor. Broadside or inline, that's all just operational nonsense. It's for operational concerns. It tells you nothing about the sensitivity. The Earth doesn't know what type of system we apply. So you'll be prepared to do everything in 3D. Whether that's broadside or inline doesn't matter. There's some sweet spots. In the electric fields, you have sweet spots. With the magnetic fields offshore, you have sweet spots. That's just in order to save operational time and money. So you need to have everything. And the client usually doesn't care where the sweet spot is, and they don't care. They want everything in one go. And the only way to get everything is with a grounded dipole.
All right. Thank you. Yeah, if you have questions, you can.
This is Ariane. I have a question regarding, do you have something, Lorraine?
No, I was just going to give instructions for the attendees to either put their questions in the Q&A box or to raise their hand in the webinar interface. So go ahead, Aurelian.
Yeah, I've got a question regarding the story that you shared with us about you being in charge, just being intern without a salary increase. What do you recommend, or what kind of advice would you give to our students and emerging professionals in attendance? Do you see this as an opportunity, or I guess many people would be afraid to get exploited over time?
No. I was not getting exploited. I was working in a geothermal company. My salary was good. So I was making more money than I needed. In fact, the money I made there funded my time in Australia completely. So it was just a matter of principle asking for a salary increase. So I was happy. And the same thing happened another half year later again. And again, I didn't get a salary increase. So it was the opportunity. You should always look at the opportunity. Money is really not what matters, in particular when you are young. It's the opportunity and the learning potential. And I learned in that situation so much because I had so many people working for me, and we made a deal. I explained to them the geophysics of what they had been doing for 10 to 15 years, and they were teaching me all of the field work and application and instruments. And when I started to become their boss, they all refused to go to the head office. We don't want to go to Denver. There's too much politics. 4 months later, everybody had a request in to work in Denver. And the data quality went from 50% bad data to only 3% bad data. Not because we improved the equipment, it's because they understood what they were doing. So the opportunity is in your learning, not in the money. And you have to stay in your center. That's it. And that center, when you are talking about professional opportunities, is your learning when you are young. And if you only go after the money, yes, I think you should go for the money. That means you get a higher paid industry job. But if you're saving 30% of your salary, it doesn't really matter whether you're saving 40% of your salary or 31% of your salary or 25%. That's what you should tell your students. It's not just the absolute value of the money. You should have enough money, yes, but so job satisfaction is also important.
Okay. We have a question in the chat. We also have another question from a student. Kurt, what are your recommendations to getting and finding and getting a sponsor? You said that that was pretty critical.
A sponsor for what? Mentor, you mean?
Mentor. Mm-hmm.
You know, the professional societies have started mentoring programs in Europe in particular, but also around the world. They're not very effective. And mentors, you don't, they can help to get to know people. Mentors are found by direct connection. The connection between people is what makes this industry work, not the connection between companies. Companies change, people connections stay. So I mentored, even while I was working in industry, a lot of scientists working for the competition, working on competitive projects. And we were careful in not talking about where we competed, but, and also the other way around. They also mentored me to some degree. You find a mentor by developing a relationship from both sides, and you will see that the mentor accepts you. Now, there's one important thing that Dr. Law, physics professor at UT in 1979, taught us when we were getting a prep course as Fulbrights. He taught us when you select an advisor at an American university and you go around and talk to them, those advisors that have a lot of time for you, they're not the right ones. Those advisors that are very busy, that don't have time for you, they have so much to share that everybody wants. That's why they are so busy. Those are the ones you should go after. So I don't know if that's right. I mean, partially and partially not. So you find a mentor over time. It's not something you do by saying, is you're now my mentor. You can try going through mentoring programs, but it happens. It just happens.
All right. There's a question from Diane. I'm really new in electromagnetic methods, but 3D CSEM that we are talking about is onshore because we had a conference last year and the person who was talking said that this is impossible at the moment, acquired CSEM onshore to eliminate more than 1 kilometer deep.
He's full of shit, the person that said this. I've been doing it since 1981. I work in Australia with a mining generator of 25 kilowatts, defined core measured 1190 meters. And my mentor and supervisor, Kiva Wozov, looked at it and says, just good luck, pure luck. And I got so pissed off, I said, well, my equipment is already in the boat, I'm going to Germany. And 3 years later, we made up, and he became my mentor for the rest of my life. So it's nonsense. It's total nonsense. This is complete nonsense. They don't know what's going on. Whoever says this doesn't know what's going on. Because this has been done since 1981. The Russians have been doing it, and all of this comes from Russia. We have been doing 3D interpretation since 1989. Anisotropic models are in use since 1992. And it all comes from Russia, from one group in Moscow. And we are still using now the second generation from of scientists from that same group. And she works with us here in Houston. And all of the ones in between, they were all from that same group. So this is total standard, and it's all over the world. So EMGS routinely provides you a 3D anisotropic model. And the Earth doesn't know if there's water on top or not. So EMGS can also do that for onshore. And we sell transmitters to do exactly this. And we have been building them. Granted, the guy who makes our transmitter has been making our transmitter for 40 years. But we've sold 4 so far, and they're all over the world. And he has been making our 20 or 30, most of them for us. So it's perfectly standard. In Turkey, 20 years of gas exploration was based on 3D CSEM. And the fields have long been sold, probably even shut down and since 15 years. So whoever said this is, I've heard this too. We had a competitor tell Shell, you cannot measure 3D induction in the borehole. And the Shell guys were laughing their head off because they were running our tool for 1 year commercial. Happens all the time, no big deal. So this guy may be a nice guy, but he's poorly informed.
All right.
And I'm not the only one. I mean, there are people all over the world that do this.
All right.
In particular in China.
Okay. We have another question. It's not easy to ask for a salary increase. How do you prepare to support a request?
Depends. If you have a salary increase on formal grounds, you usually don't get very far. If you want a salary increase because you have another job offer, you will get it almost automatically. And never assume that you cannot get a salary increase. So those are the two things. If you say, oh, this guy gets more money than me, then they say, well, you agree to it. And that's the way it is. You have to wait until salary comes around. You get salary increase because of performance. If you meet all of your objectives and make sure you have objectives and you measure that you met them, then you should get a salary increase. If you meet all of them, you should get a salary increase above and beyond what the average salary increase is. Salary increases usually happen in larger companies at the same time. And but if you do not meet your objectives, you have a real hard time asking for a salary increase unless the market totally changes. Now, the oil industry has destroyed the salary structure. Geophysicists, in particular in the oil industry, are paid over proportionally high salaries, which the companies cannot really sustain. And so geophysicists get out of the university and they have a hard time finding a job because nobody wants to pay those salaries. Just be aware of that. At least that's what I'm observing in the US.
Okay, thanks, Kurt. And that kind of leads right into our next question is, what is your view on job opportunities for geophysicists just graduating?
Oh boy. There is a lot of push, in particular in Europe, and I'm now talking about Germany in particular. They finally decided to listen to the geoscientists when it comes to nuclear waste storage, after they ignored them and the geoscientists told them that the salt domes they were using were unstable. And so there'll be opportunities there, but those are temporary jobs. They're not long-term jobs. You have to get some specialty. You have to rise out of the crowd. And so you'll find a job where you have that opportunity. There's a lot of environmental geophysics going on, and that will be increasing. There's a lot more public transport, which requires more environmental geophysics. A lot more tunnel drilling, lot of things will come online. So in particular in Europe, and this is the European part. As far as the oil industry is concerned, geophysicists and geologists have done such a good job in finding oil that unfortunately their future is in decline. What's not in decline is the big Q change. That means people like me are retiring, and there is no know-how in the oil companies. Even in the last 10 years, I've noticed it, that there's a big gap. There are all these young people that know nothing. They have some good education, but they have no experience. And they now are 30, 35 years old, but they still know nothing. And there's no senior guy to mentor and teach them. So there are opportunities to get in there. But how do you get there? Work for specialty companies and find them through their customers an opportunity in an oil company, if you want to work for an oil company. But the oil companies will be going to renewables and zero footprint. And there are opportunities there. Unfortunately, these opportunities are difficult work environments for fresh graduates because it's a job, and it's a difficult job because nobody knows what the job is. So it's a challenge. You can rise out of the crowd, but it's more difficult to do. And 4 out of 5 cases just swim and then eventually jump out of the pond and find a bigger pond to swim in. So I do not, earthquake prediction, big topic for geophysics. I can guarantee you we can see earthquakes just as good with electromagnetics as with seismics, not being done everywhere. And so there's a lot of area there which is becoming more and more important. But it takes senior guys to lead the projects in that area and get the funding for the junior guys to have the job. And we have been trying for 10 years to get some projects in that area, and we can't find the people to lead it.
All right. So I guess we have another question that leads from your response, and they ask, how do you keep the knowledge from all the people who are retiring? How do you retain any of that?
Well, that's my whole purpose in life, is to share my know-how with my next generation. So I have essentially hired a manager for my company, and fortunately, she also worked with me before, and she understands things faster than everybody else, and so it's going in the right direction, but not everybody is that lucky. I also try to work with my former students and try to get them in the right direction, but it takes project opportunities. So I have to work my ass off to get the projects, and then try to pass them on. So that's what I'm doing. But on a corporate level, what I used to do is make people write research reports and internal reports. And we are now finding that these reports are not written well enough. We are looking at reports from 10 years ago, and a very experienced scientist did a lousy job in documenting an experiment. So these reports are very important. So corporate knowledge, you have to capture through reporting, and big companies do this very well. You know, oil companies like Shell have a very good library and very good way of capturing work for the library of projects. But it's difficult, because even if you have these reports, that's why mentoring becomes important. You have to find a way to get access the old guard. And thanks to the pandemic, everybody is doing things online, which is extremely helpful. You now have access to people you wouldn't have otherwise. You try to do things online. Develop connections, keep in touch. It's difficult. I mean, I cannot even imagine how difficult it is for the younger generation to put up with older guys like me, because we get very opinionated.
Okay. Well, we have a note from Adriana, and she said for me to let you know that you are a role model, and that she says that you have supported her in her career and roles at SCG, and that she's truly grateful. So I think this speaks to your being a mentor and connecting with the next generation.
Well, I choose to be quiet now, and I'm enjoying the compliments from Adriana. And as you know, you and Adriana are some of my most favorite people on the European Regional Advisory Committee.
Well, thank you.
So,
all right. Do we have any more questions from attendees? Aurelian, do you have any additional questions? Well, Kurt, it doesn't look like we have any more questions. I will say that I really enjoyed this presentation a lot. You know, technical talks are wonderful and they're great, but getting to see the backside of the technology, the person that actually goes in and develops a method or a tool, and has developed over the years quite a robust biography that shows so many accomplishments and actually awards in recognition of those accomplishments is really, for me, as a geoscientist, and I don't get to be one very often, but for me, I really enjoy seeing that. And it's the personal connections, I think, that most people have missed over this past year. Meeting face to face, but Zoom has helped. Like you said, we can connect with people who we might not normally have had the opportunity to meet with. And some of these stories are really remarkable in that they set the foundation for a whole field. And I think that's kind of what we had the privilege of watching here today. So thank you very much, Kurt, from the SCG, and me personally.
well, thank you to everyone, and thanks to everyone for listening. One last comment is I didn't mention the word politics, because the only thing I have to say, do not get involved in politics. You never know where you end up and what regime is there. You're a geophysicist. Don't do it. Don't get involved in politics. It's always a connection to the people, not to the politics.
Well, that's an excellent point, especially as geophysicists. From working with a bunch of geophysicists for a number of years now, people move all over and they work with different groups everywhere they go. And it's a very small community. And so everyone knows everybody. So you're absolutely right. Politics is not where you need to be participating.
Okay.
All right. Well, until next time, thank you very much for joining us for this webinar. Thank you, Kurt, for presenting. Thank you, Aurelian, for co-hosting. And thank all of you attendees. So look forward to our social media posts for our next webinar that will be coming up. Have a great day.
Thank you. Bye-bye.
Bye-bye.
Bye.